Good day, I'm Maile Matsiba. Welcome back to our channel. Today we're continuing with class test 2 of 2011 of our CRR 123, which is the second chemical engineering module at the University of Pretoria. We're looking at part 2 of class test 2 of 2011. In part 1, just a little reminder, in part 1 we answer the question that says calculate the percentage access reactant based on reaction 1. So now in part 2 we're going to answer B and C. Now B says calculate the percentage yield of C. So let me just write down the equation of calculating the percentage yield of C. So the percentage yield of C is equals to C that is produced all over C that is theoretically possible multiplied by 100%. Now if you look at this, you'll realize that the C that is we have C that is produced all over the C that is theoretically theoretically possible multiplied by 100%. Now it's easier to find out the C that is produced because we can actually look at our reaction equation and also look at our analysis, because we are told from the problem statement that the analysis showed 25% A, 20% B, and 10% D. And in the first part, when we did the calculation, we found when we chose 100 kilomole of the analyzed mixture, we were able to find out that out of the 100 kilomole, C was 45 kilomole. So C that is produced already, we know that it's 45 kilomole. So one thing that we're going to do a calculation on is to actually calculate the amount of C that is theoretically possible. And if you're going to calculate a C that is theoretically possible, we're going to need this reaction. And it's important to understand that C that is theoretically possible depends on the limiting reactant. And in the first part, we're able to find out that A, because the problem statement is telling us that unknown quantities of A and B were charged into the reactor initially. So after we did the calculations, we found out that A was actually in excess and B was limiting. So from this reaction, if you're going to calculate the C that is theoretically possible, we're going to need to use the C, or rather B, because it's the limiting reactant. And the reason for that is that the furthest the reaction could go is to actually consume all of the B, because it's limiting. Why? Because the A won't have any more B to react with, so it's going to be remaining. So hence the C that is theoretically possible is going to depend on the B. So now I just want to do a little calculation calculating the theoretically possible C, and then I'll come back to the equation for percentage yield C. So let me just write here that C that is theoretically possible is equals to, now when you look at the reaction equation, you realize that the ratio of B and C is actually 2:3. And after we did the calculation in the first part, we found out that initially there was actually 40 kilomole of B that was put in the reactor. And if we know how much of C, or rather how much of B that was put in the reactor initially, and B we know already that is the limiting reactant, we can easily calculate the C that is actually theoretically possible. And with that said, we can just simply say that C that is theoretically possible is actually B that was initially loaded multiplied by 3/2 from the ratio of the reaction. So with that said, therefore the C that is theoretically possible is equals to the B that was initially loaded. We calculated it to be 40 kilomole in the first part, and then if you multiply it by 3/2, you can use your calculator. It gives you 60 kilomole of C. So that means that the C that was actually the maximum amount of C that you can actually be able to produce from this reaction is actually 60 kilomole, right? But now we need to calculate. Then now when we have this information, we can go then calculate the percentage yield of C. So I can just go back to the equation and say percentage yield of C is equals to The C that is produced, already we mentioned that we calculated it to be 45 kilomole, and all over the C that is theoretically required is 60 kilomole, all multiplied by 100%, and now that gives you 75%. So with that means that the percentage yield of C is actually 75%. So that answers question B, which says calculate the percentage yield of C. Now, when you come to question C, says calculate the yield of D. Please notice that the percentage yield of C, or the percentage yield and the yield, are not so much the same. So yield can be expressed in different ways, but one thing that we can actually, let me just write the equation of yield of D. Let me just say yield of D is equals to, the yield of D is going to be the amount of D produced all over the amount of the limiting reactant. It's also entirely dependent on the limiting reactant, because that is actually what measures how far the reaction can go, and also, or rather subsequently, it tells us how much of D you can be able to produce. So the yield of D is simply going to be the amount of D, let me write it, D produced all over, how do I express this one? Well, I can just simply say that all over the amount of the limiting reactant. So all over the amount of the limiting reactant, right? And with that said, you can simply say the D that is produced in question, in part A, we found the D that is produced, we calculated it to be 10 kilomole, right? All over the amount of the limiting reactant, I've already mentioned that it's actually 40 kilomole. So it's 40 kilomole, right? B. So therefore the yield of D is simply 10 kilomole per 40 kilomole B. So which means for every 40 kilomole of B, you're going to produce 10 kilomole of D. That brings us to the end of our part 2 of our class test 2. So that answers question 1. This actually brings the end to question 1. I'll come again I'll upload a video of part 3, which is going to be based on question 2 of the same class test. So thank you for your time, and I hope to meet you again in our next video.